So students, today we will learn method of undetermined coefficients. Okay. Last week we have learned how to solve homogeneous differential equations, higher order homogeneous differential equations using the characteristic equation. This week we will learn how to solve the non-homogeneous differential equations. Let us understand it with the help of an example. Let us suppose that I have a non-homogeneous differential equation y double dash plus 3y dash plus 2y is equal to 6. The term on the right hand side is making this differential equation non-homogeneous. Okay. So now I have a second order differential equation, okay, and I want to find the solution. So I will break the procedure into two parts, complementary solution and particular solution. The term written on the left hand side, when I put it equal to 0, I will get YC, complementary solution. The term written on the right hand side, if I consider the entire differential equation, I will get yp. Now the first step is to solve the first equation. So as we learned in the previous lecture, how to solve a homogeneous differential equation, we will seek for the characteristic equation. We will say that this differential operator is m. For example, here I can see d2y by dx square. So if d by dx is m, then d2 by dx square is m square. Then d by dx is m, and then here no derivative, so just 2. Okay, now I will factorize it. I will find the two roots. M is equal to -1 -2. Now the rule to find the solution of a homogeneous differential equation is that we say y is equal to c1 e to the power first root x plus c2 e to the power second root x. X is the independent variable d by dx. Right, so this is my solution for the homogeneous differential equation, but because in this case I have two solutions, complementary and particular. So for the homogeneous part, I will call the solution yc, and for the particular part, I will call it yp. And for the final solution, I will say that my final solution will be y is equal to yc plus yp. So this is the specific rule. Okay, now I have obtained yc. Now I will work for yp. Yp is the particular solution. Now, what is yp? This is a question. Now I will look at the given differential equation carefully. I will see that I have here 6 on the right hand side, a constant. Okay, so I will assume that the particular solution is a constant. I will say capital A is a constant. Okay, so I'm saying yp is equal to A, inspired from the right hand side of the given differential equation. Okay, now if yp is A, what is its derivative? It is a constant, so its derivative is 0 and its double derivative is 0. I'm going to put these values because I'm saying that let yp is a solution of the given differential equation. Okay, so I'm now going to substitute these values here. Yp for the non-homogeneous differential equation. I will put a p here, p here, p here, and then I will put the value for yp double dash, yp dash, and yp. Okay, so I will substitute these values here, and I will compare the coefficients of the like terms. Let us do it together. I know that y double dash is 0, y dash is 0 for this case, right? So I have only got 2 times y. So it is yp. 2yp is 2a is equal to 6. I will cancel and then I have a is equal to 3. Okay, so I know that the next rule for the non-homogeneous differential equation is that y is equal to yc plus yp. So yc is the complementary solution we have already worked on, and yp is 3. Okay, so this is the final solution of our non-homogeneous differential equation. And we have started with the very easy example so that you understand the method well. Now let us look at the table. This is a very important table for the trial particular solution. Okay, so kindly go through this table. There are 12 rows in this table, and let us go through these rows one by one. For example, if a constant, any constant, for example, in this question we had 6, so your YP will be A. If it is a polynomial of degree 1, 5x plus 7, then your particular solution is ax plus b. If it is a second order one, you will consider ax squared plus bx plus c. Now, please look at row number 3 very carefully. Here I have only got 3x squared minus 2. I do not have any term with x, but for the trial particular solution, I will have from ax squared till constant all the terms ax squared plus bx plus c. Let's say that it is cube, then I will consider all the terms ax cube, bx squared, cx, e. Okay, and now let us look at the fifth row. It is very important. It is a trigonometric function sine for x. So I have a cos 4x plus b sine 4x. Okay, even I have cos, I will have the same trial function. Now I have exponential function, an exponential function in row number 7. So I have, because it is not repeated, so I will only consider e5x. But here you can see in the coefficient, instead of the coefficient, constant coefficient, I have 9x minus 2. So I will consider ax plus b. Similarly, here you can see x square. So I have ax square plus bx plus c. Then I have here the 10th, row number 10 is extremely important. Please read it very carefully. I have the exponential and the trigonometric product. So what am I going to do? I will say a cos 4x, b sin 4x, and I will multiply both terms with e to the power 3x. 5, next 11, row number 11, I have 5x square sin 4x. Now I have a polynomial and a trigonometric function. Remember that for the polynomial, we have learned that whatever the highest order of this polynomial, degree of the polynomial is, I will consider the entire polynomial for the trial solution. Therefore, I will have x squared. So I will go for x squared, ax squared plus bx plus c. Now I have sine 4x, and for sine 4x, I have learned that I will go for sine 4x and cos 4x both. Therefore, I will write it twice, cos 4x, sine 4x, and then as the coefficient here, I will consider the polynomial here, the entire long polynomial here. Okay, so we have here ax squared plus bx plus c, ex squared plus fx plus g sine 4x. Okay, so please remember this rule. Now row number 12 is very important because we have the product of three things: exponential, polynomial, and trigonometric. So now I'm going to use these here. Okay, now this is part 1 of chapter 4, exercise 4.4. I will come back with part 2 and part 3 because it is a very important chapter and we cannot upload videos longer than 12 minutes. So we will go to the next part, part 2 and part 3. And meanwhile, you will solve example number 1 and example number 2 of exercise 4.4. Okay.